So is there anyone know about what exactly the deep learning? So I can say it's a advanced of machine learning. Okay. So the main difference of the machine learning and deep learning here we have some kind of historical data. Okay. And with help of that one, we can train the algorithm and we can build the model, and that model we can do some kind of future predictions. Okay. And in this particular situation, so the machine learning which is not mimic the human brain. Okay. But when it comes to the deep learning and how the human is learning, in the same way the deep learning also can learn it. Okay. See, let's have some examples. Let's have some kind of examples. Mm, yeah. This is your starting point. Okay, this is your starting point, and this it could be the destination. Okay, see, you have to start from here and you need to reach to this particular location. Okay, so and how the human being can learn actually, so the location and the path and everything, and he can start, maybe you can we can first of all, if someone already know this location, okay, so he can bring another person and this together can start traveling from here to here, right? So one time is fine. Okay, next time this guy is not available. Okay, and then how the same person can reach to from this particular location to this location? So by the time of traveling from here to here, he can notice some information. Okay, he can notice some information. He is learning. Okay, he's learning himself. Okay, I mean his brain is learning, right, the path and everything. Next time, without this person, if this the person can be travel from a location one to location a two. Okay, this way the human brain is working, right? The same thing, the same thing, the deep learning also can be worked. Let me take another example. And you have the cat image and you have the dog image. Okay, so you just bring a person and it doesn't have any kind of information what exactly the cat and what exactly the cat. Okay, so the person is like, is a 4 years old guy. Okay, he's a 4 years old guy, and you just showed that, cat and dog, and you can, this guy, you have to be do the question to this old years 4 years old guy. Okay, this guy is unable to find the which is the cat and which is the dog. But the same thing, you can bring another person, he's having the 20 years old. Okay, and then if you show that the cat image and dog image, the person, this 20 years person, can be easily recognizing that, so what is the cat and what is the dog, right? And how it is happened, because of here this guy is not look as of now, he doesn't know what exactly the cat and what exactly the dog. But if you train him, or else once if you teach him, okay, so this is the cat and this is dog. The cat is having very, four legs, and it's having the brown color eyes, and it's having some kind of, beard, and and it could be the very small when compared to the dog. This kind of information you're training with this guy, and you're showing some kind of image. That image can be trained inside of his brain. So next time if you show the same thing, he can easily recognize it, right? So how these things are working inside of the human being. We having the brain having some kind of functionalities. Because of that functionalities, he can able to remember the each and everything, right? the same thing the same thing we have to implement it in case of deep learning. Okay, in case of deep learning, are you guys are following or not?
Yes, Sanjan.
Yes, sir.
So let me take, in case of machine learning, I just want to show you some examples. It's not example that difference between the machine learning concept and Yes, fine. Now, if it is the machine learning, then you have the historical data, right? You have some kind of historical data, and you have to train the data with the different algorithms, and then which is creating the model, and the model, it can be used for some kind of future predictions. This is exactly the machine learning can work, right? But when it comes to the deep learning, this is not same. This is a little different. So here we have data. Okay, here we have the data. Okay, so the data which is having the different inputs, right? X1, X2, that means the data which is something like a column 1, a column 2, and column 3, and Y as well. Okay, X1, X2, X3, and X4. Okay, like we have a data something like this. Now, so these are the inputs. These are the things we can say that it's a input variable. These are the inputs. We have to be providing that neurons. This is the neuron 1, this is neuron 2, and this is neuron 3. What it is? Neuron in the sense, inside of the brain you have some neurons, right? Okay, or else in a body we have some kind of neurons, and the neurons can be bring some information to brain actually. Okay, from sensing organ to brain, it can be carrying some kind of information. So here the input we are providing the neuron 1, and this is neuron 1 2, this is neuron 1 3, and this is neuron 1 4. This is layer 1. Okay, this is layer 1. Okay, this is the input. So this is the input which is taking the input to the new neuron. This X2 could be the input for the neuron 2. This X3 could be the neuron input for the neuron 3. X4, it could be the input for the neuron 4. So this is hidden layer 1. Okay, so simply we can say that it's a hidden layer. These are the layers which is not visible, so that we are calling it a hidden layer. Okay, so inside of the hidden layer 1, okay, so you can representing like h11 or h12 or h13 or h14 or n something else. So this is the neuron. It can be generating some kind of output, because of inside of this one we have some kind of activation functions. So the neurons which is having the inside of, we have some kind of activation functions. Okay, this activation functions can be generating the output, and this output could be input for the next layer of hidden. Okay, this is hidden neuron 1 2, this is 1 2 2, and this is 2 3, and this is 2 4. So this is the input. It will be, this is output. It will be input for the next layer of all neurons. The same input, the same output, it could be input for the all neurons for the next layer. Okay, in the meanwhile, the hidden neuron 2 also can be generated some kind of output. This output could be input for the next layer of all neurons. Okay, and same thing, you have to be input for the next layer, and here also. So this is the way, one output of the one neuron can be input for the all the neurons in the next layer. Okay, this is the way you should maintain the, you have to creating the different hidden neuron 1, hidden neuron 3, layer 1, layer 2, and layer 3. So here also we have it could be input, output of the one neuron can be input for the all the neurons in the next layer. So this is the way. Okay, this is the way you can okay, and it can be generating the output, right? So this is your output variable. Okay, so you can say that it's a y, so which is generating the y hat. Okay, but you have some kind of actual output, right? So y is your actual output and you're getting the y hat, right? So the difference between these two things, we're calling it say cost or error. Okay, here we are getting some error, right? For example, what I can do, I'm providing some kind of inputs to this particular neurons. Inside of the neurons we have the activation functions. The activation function could be available here as well, here as well, here as well, and here also, here also. All the other neurons can have the activation functions. The activation functions can be generating the okay, output. So finally the last hidden neuron can be generating some output that you can say that it's a predicted output. Okay, but we have some kind of actual output, right? So the difference between the actual and predicted, that we are calling it's a error. Okay, for first training, for first iteration or first iteration, okay, for first iteration we are getting the first error, right? Okay, now what I can do, so after you're getting this error, and with help of this one I have to do that. So this entire process we are calling it a forward propagation. forward propagation Forward propagation. So for example, we have some kind of inputs, and these inputs can be given to the layer 1, hidden layer 1, and which can be generating some output. That outputs could be input for the next layer, and next layer outputs could be the inputs for the next layer, and so on. And finally we are getting some kind of output. That output we are calling it say error or else a cost function. For first iteration we are getting the one cost function. Now what I can do, I have to go to the backward propagation. Backward propagation. In case of backward propagation, with help of this error, what I can do, I have to be updating. See, while you're giving, so make sure that, and so when you're giving these inputs, and we have to providing some kind of weights. Okay, not we cannot provide directly inputs to the neurons. So what I can do, I have to provide some kind of weights over here. Okay, this is weight 1 and weight 2 and weight 3. Okay, so this input and this weight could be multiplied to each other, and this entire thing could be input for the activation function or neuron, and it can be generating the output, and along this output we have to provide the some kind of weight over here. Okay, so every time, for every activation function, not only output, it might have some kind of weights as well. Clear? This weights also we have to be providing by the user itself. So this is the way you have the weights over here. Okay, so not only inputs, we have inputs as well as we have weights as well. Okay, we have the weights as well. So what I can do, I have to go to the backward propagation, right? So when I have the backward propagation with this error, then I have to update the weights, and here I have to update the weights, update the weights, and update the weights, and update the weights. After you updating the weights, then what I can do, again I have to do the one more iteration. When I do the one more iteration, this again, we already weights are updated, right? So with this inputs and with existing inputs, and again we have to do that forward propagation. By the time of forward propagation, okay, what I can do, this inputs and this updated weights can be given to the input for the activation or neurons, and it can be generating output, new output, and updated out. We have updated weight as well as we have the new output, right? And with help of this one, which can be giving input for the next neuron, and so on. Again, we are getting the, finally we are getting the y hat. That means your predicted value, and we have already some kind of actual output, right? So the difference between these two things, that we are calling it say cost function. So here the cost is, for example, here the error could be, for example, 15. Okay, for next iteration the cost, it was 20. So if the 20 means what, 8 should be decrease, sorry, weight should be increase or something, whatever it is, depends upon this cost value. So we have to be updating these weights. When you're updating these weights, maybe the cost can be reduced, for example 10. So when cost value is reduced, again we have to updating the weights, and so on. And this entire process, the one forward propagation, one backward propagation that we are calling it say one iteration. What is iteration? Iteration means one forward and backward that we are calling it say iteration. In case of forward propagation, the result it could be your predicted value, and in case of backward propagation, our task is that we should updating the weights. Okay, clear? And so on. So for every time, for every iteration, what I can do, you have to go for increasing, updating the weights. When you're updating the weights, the cost function or the cost value can be reduced. Once it is reached the minimal value or minimal global minima, here what happens? After it is reaching the global minima, if you're updating the weights, then again the cost can be increased. At what level you are getting the global minimum, that where it is we are getting the global minima, that particular situation we have some kind of weights, right? That are the weights, it could be final weights. Okay, so inputs is never changing, only weights should be changed. So we have to finalizing the updated weights, and we have to be finding the optimal weights. How we can do that? With the help of the forward propagation, backward propagation. Every time we are getting the cost, and meanwhile in the backward propagation we are updating the weights, and whenever you're getting the global minimum, so your weights could not able to update, or else it can be increasing the cost value. Okay, so that area we should figure out actually. Clear? So at what, whenever we have the global minimum optimal weights, then you will be reaching that it's a minimal cost value. So when it is reaching the minimal cost value, that means it's a optimal weights. With help of that optimal weights, and we have to use for the next values or new values. I hope you clear my point. How that machine learn, how that deep learning is working. Did you got or not? Hello.
Yes, sir.
Yes.
If you're not to get this information, I can explain one more time.
Got it.
Got it.
Okay. So in case of deep learning, make sure that you have the two things. One is the forward propagation. Forward propagation in the sense, giving the inputs to the neurons, giving the inputs and weights to the neurons. Neurons can be generating outputs. That output of the one neuron can be input for the next layer of the all the hidden neurons. Okay, that way you can able to finding the cost value. So here you are getting the cost value. Okay, and in case of backward propagation, what we are doing actually? In case of backward propagation, what we are doing? You're updating the weights. Okay, when you're updating the weights, the entire process we are calling it say iteration. Iteration means one forward propagation, backward propagation, that we are calling it say iteration. So this are the iteration can be repeated until unless we are getting the less cost value, or else we have to repeat this process until unless we are getting the less cost value or zero cost, or else weight should not be updated. Weights can be constant. Until weights cannot be updated, I mean until the weights cannot be changed. Okay, so we have to repeat the process, or else you have to we have to repeat the process until unless your cost value can be zero. Okay, so then only you will be getting the updated weights. When we have updated weights, that entire network, we can give the any new input, we will be getting the correct output only. Clear? So these are the steps we have to follow it. See, if you go ahead with the if we go ahead with whether it is the if it is the neuron, if we have the neuron, the internally the neuron which is having the, it can do the two things. One is the multiplication, one is the activation. So here we are getting the input, right? For example x1, and as well as we are getting the weight as well. Okay, so here what it can do, it can multiplying the weight and input, and this weight and input, it can giving the okay, activation function, this result x1 and w1, okay, or we can say that it's a z. So this x1 and y1 we are giving to this particular activation function. So there are different kind of activation functions are there. ReLU activation function, sigmoid activation function, softmax activation function. Okay, like we have a lot of activation functions are there. Okay, so we can use any one of it, and we have to be build the network, and we have to go with the cost function, right? When you go ahead with the cost function, so we have different kind of cost functions are there. Okay, I can tell you what are gradient distance, or else okay, and different other cost functions we have it, I can let you know. And when you're doing the updates, right, backward propagation, this is okay for forward propagation. When you go for the backward propagation, we should update the weights, right? For updating the weights, we have the formula. Okay, we have a different kind of formula again. So for updating the weights also, we have a different algorithms, and we have the different kind of cost functions, and we have different kind of activation functions. When you know this all things, we can easily creating the any neural network. Okay, you can easily creating the any neural network. Clear?
Clear.
Yep. So as a data as a deep learning, in a deep learning we have a three different kind of concepts we have it, or networks are there: artificial neural network, okay, and the CNN, convolution neural network, and recurrent neural network. So these are the network, this is network, right? These are the networks, are three different networks are there, either activation, uh, artificial neural network, and convolution neural network, and recurrent neural network. Okay, see this ANN, it's simply whatever the task we can do with help of the machine learning, that all tasks we can do with help of the ANN, like classification, regression, clustering, anything we can do with help of the ANN. But when it comes to the CNN, it's a purely dedicated for video processing or else image processing. Okay, and RNN, it's dedicated for text text related projects. For example, review recommendation, movie recommendations, or else reviews. And so text, whenever where text analytics are there, then RNN can help you. Images and videos processing, or analysis, we can go ahead with the CNN. And like how we can do with help of the machine learning concepts, or how we can do the machine learning projects, same things we can do with help of the ANN as well. Okay, so these are the three type of neural network we can build it. Okay, so fine guys, so by tomorrow what I can do, I can list the all the activation functions, I can list the all the cost functions, I can list the and all weight updated, how we can use the updated weights methods. Okay, and we can go ahead with at least one project, either ANN or CNN or RNN. Okay, and there we have the Keras, PyTorch, TensorFlow. These are the libraries or frameworks we have it to build this kind of network in Python programming languages. Clear, guys?
Clear.
Yep.
Yeah.
That's for today's session in deep learning. We'll catch up tomorrow for for discuss some more information about deep learning. Okay.
Can you please upload the sessions onto Canvas?
Yeah, I will do recording. So I'm not getting much time on it. Okay, I can do it. I can do it, guys. Can anyone message me in next 2 hours so that I can able to upload it?
Thank you so much. So do we have Python today?
Mm, not guys. We don't have any Python session, guys.